चल रहा है वो shit, चल. So here we are just seeing what is the hydraulic system and its component. So these are the important components of our hydraulic system. First one is the actuator, then direction control valve and power pack. You know what is power pack? Power pack is a component having two substitute components. First one is the pump and another one is the tank. You know, in the tank there is a fluid is present, and you know along the in this fluid either maybe a gas also, because under compression gas becomes fluid. So working fluid may be a liquid or gas, but in case of hydraulic system it is a fluid, and in case of pneumatic system it is gas. So this is the pump. So this is the direction control valve and this is the actuator. So what is direction control valve? Direction control valve is a device which regulates the direction of the fluid. You know that there through this pump or throughout the system there are two arms. First one is the low pressure arm and another one is the high pressure arm. So to regulate this low pressure and high pressure, we are using this direction control valve. To explain this concept more better way, I am going to show you a video.
Hello, this is Carl from lunchboxsessions.com, and
just see the video and I will explain it after.
2 on directional control valve basics. We will be looking at 4-port directional control valves that feature a blocked P-port when in the center or neutral position. 4-port directional control valves typically have the 4 labels P, T, A, and B. The P-port is for supply from the pump, the T-port is for the return to tank or reservoir, and the A and B ports are typically known as the work ports and are connected to the cylinder. Let's get started with a 4-port two-position valve that does not have a center position. On the symbol, you see P to A porting to extend the cylinder and P to B porting to retract the cylinder. On the actual valve spool, you will see a cylindrical spool sliding inside of a cylindrical valve bore. The spool has large diameter areas called glands and smaller diameter areas called undercuts. This valve, with its 4 ports and 2 positions, is popular enough to extend and retract the cylinder, but does not allow the user to stop the cylinder mid-stroke. The spring inside this particular valve returns the valve spool to the P to A position whenever.
Look, student, what is this? Is the complete hydraulic system. So here on my cursor you can see this is the actuator. So this is direction control valve and this is the power bank. So in this power bank we are having this pump here. Okay. So through this pump, this fluid is sucked in and it is supplied to this actuator. Actuator is here is linear type of actuator, not rotary. How this actuator study I will show you in the next video. Okay. So you can see here this is the symbol of this direction control valve. You can see this direction control valve changes its position to move this piston up and down. So to move this piston up and down, we have to change the direction of this high pressure fluid. When the high pressure fluid is at as bottom, then this piston goes up, and when this high pressure fluid is at having entry at tops, then this piston moves on down. So by changing the entry or by changing the direction of this high pressure fluid, we can control the movement of this actuator here.
The lever is released. Notice that the relief valve is taking care of limiting maximum system pressure whenever the cylinder...
Some of you may have a problem that what is this? This is the relief valve. You know what is relief valve? Relief valve, it is a type of safety valve which is used to reduce the excess pressure to avoid the damage to the entire system.
Is deadheaded against the fully extended or fully retracted position.
Here you can see that this is the in this two position valve. This is the first position where the high pressure fluid is enter at bottom, and this low pressure fluid is removed from this low pressure side here. So when you want to move the piston downward direction, to move this piston downward direction, we alter the direction of this flow. So here this second position here, when you alter the direction of this flows, and you will get the piston moves downward direction.
Now let's change to a 4-port 3-position valve. In the symbol, you can see that a center position has been added along with a second spring. The 2 springs in the symbol mean that the valve...
Actually, now they are adding this third position. Now this valve become 3-way 8-position valve. How this name comes, I will show you as the subject. We will go further deep inside the subject. How this symbol is to be drawn, I will teach you all this. For this, this is the starting now, so just focus slightly on it.
Is spring centered. Notice that the P port is blocked when in the center position. The relief valve is limiting system pressure. The A, B, and T ports are also blocked, making this a closed by P to A flow, both sides of the valve spool, but again is not...
Here what happens now, the direction control valve is going to change the direction of this flow.
Not connected to any other port at this time, so it is blocked. Activating the valve shows us that we can provide P to A flow. So it is blocked. Activating the valve shows us that we can...
Now what happened at this instant? Yeah. At this moment, they are alter the direction of this flow, and this high pressure liquid is transferred at the upper port. That's why the pressure at the upper side increases and pistons start moving to the downward direction. So in this video, I clear you that how the direction control valve actually works.
We provide P to A flow to extend the cylinder, or P to B flow to retract the cylinder. Releasing the handle shows that we can in fact stop the cylinder mid-stroke. This is a common feature and is desired for many hydraulic systems. It is especially popular for horizontal cylinder installations, but as we will soon find out, it is not great for a vertical installation. In this animation, the valve seems to perform just fine, but can you imagine what happens as the cylindrical valve spool moves back and forth many thousands of times?
This is the first position, this is second position, this is third position. So, and the directions are first, 2, 3, 4, 5, 6, 7, and 8. So this is the 8-way 3-position valve. How I count this position, how I count these ways, I will explain as a subject. We will learn further. So in this moment, just you have to notice that these are the 3 blocks. This is 1, this is 2, and this is 3. So all these 3 are the position of the valve. On this valve, there is a straight movement of this fluid. Here the movement of fluid is blocked, and here the movement of fluid is altered. I mean, it means change. At this moment, from this lower valve, this high pressure fluid is moving, and at this position, the high pressure fluid is moving through the upper port from here. That's why the piston moves on downward direction. And in case of this first position, the high pressure fluid is transmitting from this lower port. That's why the piston moves upward direction. I will show you here. Here you can see that this is the first position where the high pressure liquid is moving, is entering to this lower port. That's why the piston moves in upward direction. Okay. Easy one.
systems. It is especially popular for horizontal cylinder installations, but as we will soon find out, it is not great for a vertical installation. In this animation, the valve seems to perform just fine, but can you imagine what happens as the cylindrical valve spool moves back and forth many thousands of times through the same valve bore? That's right, wear will start to occur and internal valve leakage will develop, and we will find that our cylinder is slowly drifting.
Now we are going to study the another concept, which is actuator. So we are again having another video. So here we are.